I am Jim 5.0 and I have here a connecting rod from one of the General Motors LS series engines, the LSA V8. This is a connecting rod used for supercharged application. The LSA engine does see application use in both the ZL1 Camaro as well as the Cadillac CTS-V. The LSA connecting rod uses a rather industry standard of manufacture, and that is pressed powdered metal sinter forging. What that is powdered metal is poured into a pressure form and compressed very highly into a initial workpiece. That initial workpiece is then ejected from the pressure mold, taken to a furnace, and heated to cause molecular bonding between the metal particulates within the initial workpiece. That piece is then brought into forging temperature and then taken out of the furnace, placed into a fully enclosed die, and then struck once to cause densification of the material within the workpiece and also to bring the workpiece into its more final shape. After the striking step, the connecting rod is taken out of the striking die, and the excess material flash that is actually generated from that is machined off. The flash is created right here, also on this side up here at the upper end of the connecting rod, and again right here. It is machined down flat to cause a flat surface for installation on the connecting rod so that it could also work in conjunction with another connecting rod on that same journal, and both of these rods together could work to turn two pistons. This connecting rod has not seen installation into an engine. As you can tell, the end cap has not been cracked off. You can see that there is a cracking machining line machined into the inside of the journal over here, at which time a special tool is used to pull the connecting rod bottom end in half. And what happens is there is a part line that creates right here, and the end cap is now separated from the rest of the connecting rod and is now ready to be installed and put onto the crankshaft within the engine. A little more on the LSA connecting rod is that the LSA engine and its connecting rods are meant to see supercharged application. For example, in the Cadillac CTS-V, the LSA is tuned to create 550 horsepower out of that power plant. In the Chevrolet Camaro ZL1, the LSA power plant is tuned to create 580 horsepower. As you can see, this is an I-beam construction, but it is a rather beefy I-beam design. For comparison, here is another sintered forged powdered metal connecting rod, but this powdered connecting rod is for a naturally aspirated engine. As you can see, the LSA connecting rod has more material width, and also looking at it from this alignment, you can see that the LSA shank is wider than the naturally aspirated connecting rod. At the top of the LSA connecting rod, where the wrist pin for the piston goes into, from this side you can see that it is machined into a trapezoidal shape. The bushing is already pressed in at this end of the pin on the pin side journal, and from here the purpose of this machining is to lighten the connecting rod at the top end where the piston is. Interestingly, at the top, there is not an oil hole that is drilled. On this connecting rod for the naturally aspirated engine application, you can see there is an oil hole that is machined. From what I understand, the CTS-V LSA connecting rods have that oiling hole that is machined up there, but this one for some reason does not. Overall, the LSA connecting rod is a very sturdy and durable design, and it is probably capable of supporting up to 600 horsepower, or maybe a little bit more, rather reliably and durably for several 100,000 miles within an LSA engine. For those of you looking to build LSA engines, I would say that the stock LSA connecting rod is actually a very good choice. But if you're going to push your engine well above 600 horsepower, you might consider looking at billet machined H-beam connecting rods or billet machined I-beam rods. But other than that, if you're going to be around the 600 horsepower or less range, the stock LSA connecting rod is not a bad choice at all.